So basically, I'm going to make a short video, okay, operation short video of the system. So right here we have a switch, okay, is a fan controller. The sound has stopped. This switch is basically for the ventilation fan in the roof to take off any hot gases, hot air, or whatever that has built up in this chamber, because the inverter is kind of installed in an enclosure, kind of internal lobby. Okay, it doesn't have direct access to ventilation from outside. So we have a fan there that will draw in air from the outside or from the sitting room or from any point, and then eject any available residual heat in this enclosed space, kind of internal lobby. So the two inverters are actually on. Okay, let me explain the components. This is inverter 1, this is inverter 2, and then right under it are the two lithium packs. Okay, each of them are 10 kilowatt hour batteries. Okay, 10 kilowatt hour. So this is a pack info. All right, I enter. The battery is at 53.45 volts, and the current is 19.51. I take it down, follow the arrow there, take it down, and then I enter. I can immediately see the capacity. It's still at 87%, okay, remaining 174 AH out of 200 AH. The second battery also, and let's look at it. I press the main menu. I'm looking at pack info. The arrow is right there. Okay, I enter. I can see it's 53.45 volts and 19 amps current. I can step down, follow the arrow there. Capacity is 19.24 amps. Step down, capacity. I enter. So I can see it has 74% remaining. So 148 AH remaining out of 200 AH. Okay. All right, so that's it about the battery operation. So now I have a circuit breaker that brings in power from the battery into a consolidation box. It's a DC energy, DC power consolidation box, kind of like a bus bar. Okay, it consolidates energy from inverter 1, inverter 2, the DC component, and then integrates it with the energy coming from the batteries. Okay, it's all in this box here. By HQ1 Energy Systems. All right. Now, the next one, these are circuit breaker DC input output protection boxes. Okay, it contains fuse, modular fuses, surge protected device, DC. The circuit breaker is 125 amps Schneider. Yeah, that's for battery breaker 1. Remember, each of these inverters has two PV or solar energy photovoltaic cell input points. Okay, photovoltaic array. All right, because what we did there was we have 32 panels, 450 watts each. So we did a series of parallel connections in such a way as to optimize the energy we could extract from the sun. So this inverter 1, the master, is able to accept up to 4,000 watts. Inverter 2 up to 4,000 watts. Okay, or rather, each port of inverter 1 can take 4,000 watts. So we have like 8,000 watts coming in from the sun, supposedly coming in from the sun, and this is another 8,000 watts coming in from the sun. So these are the circuit breaker protection circuit breakers that control it. Okay, the circuit breakers are all on when it's on up position. When it's on down position, it's stripped and it's off. Okay, so right away, this is for the second inverter. Now here we have another set of circuit breakers. Okay, this is the AC input output protection box. What does it do? If you want to charge with mains or NEPA, right now we are completely off-grid, so we are not charging with mains. If you want to charge with mains, we put this on. Okay, it sends power to the inverters to charge it. So you have this is an AC surge protected device. This is also an surge protective device with earth leakage sensor. It's actually what is called an RCBO. Okay, it's a residual current breaker with special lightning protection features. It's 30 milliamp, very safe. You still have another one. After it goes through this, it goes through the last layer of protection. This is Wi-Fi enabled. It's IoT enabled. You could monitor it via your Google app or your iOS operating system. For this one is the output of the inverter. Okay, this is basically for charging the inverter with mains, so we don't need it for now. This, when you put it off, there's no power in the house, but the inverters are still on. Okay, so right now I'm going to put it back on to send power into the house, to the building. So this is basically an AC or AC input output protection box. This side for the input to charge, and this for the output. Okay, in this particular one that brings in the input, you can actually make some selections. You can do a lot of iterations on the voltage coming in, the current coming in. You can tweak it, you can trim it, you can set the trip points and everything on it, and you can monitor it real live online on your mobile phone. The same thing with this. Okay, for this one you can set up values, temperature, maximum temperature values, minimum temperature values. You could set the maximum current drawable from the inverter system. Okay, if you want to overload it, it's going to trip, because you can set trip points. Okay, trip points, alarm points, everything monitorable from your mobile phone. All right, so that's it. So this gives power to the building. Now right here, when this gives power, it brings it to this other box. This is an automatic changeover module. Okay, when you open it, you see three items. This is the main supply. It's down for now. This is the changeover module, and this is the one coming from the inverter down here up to this point. So this is the inverter supply. Right now the inverter supply is switched on, so that's why you are able to have power. If I need to trip the inverter supply, it goes. Okay, so the inverter supplies to this point on the changeover module. So it's right now we're on source A, which is the upper one, which means we are on inverter. Now on top of it, right on top of it, you have a bypass. So if it goes down here, okay, this changeover knife switch, when it goes down, it's on mains, but we don't have mains currently in the building. That's why you don't have power. But up there where you have the inverter supply, it actually oscillates between anything that this automatic changeover module brings out goes to this mains, goes to this inverter where I labeled inverter supply. Okay, so right now we're going to take it back to that place to have power. We are completely off grid. So this is how it works. So what I'm going to do now, I'm going to shut it down. Okay, I'm going to put up the inverters in sequence. I'll put up the master. It's not producing again, but it's still being charged with solar. You can see right now, this is the solar icon. Okay, it will be charging with solar. You see the batteries are charging now. You can see the arrow coming from the PV panels to the inverter and then to the battery. You can see how the arrow moves. The arrow is pointing at the battery, but it's originating from the PV icon that's right here. Okay, so it's charging, but the inverter is not generating power. Okay, when it's generating power, you will see the light blinking up there, and when it's charging, the middle one, when it's fault mode, it shows this. So right now, what does it mean? It means that the MPPT charge controller solar input is going right there into the inverter and going to the battery also, and then the battery is charging. Okay, so let me put off the inverter. So there's no power in the house. The minute you put off the inverter, the vent fan goes off. It's tied to the output of the inverter. So right now the batteries are charging via solar, but there is no output of power coming from the inverter. So I'm going to knock off the circuit breaker from the solar so that the system will be completely dead. So I'm going to knock it off. Port 1 of inverter 1, port 2. Watch what's going to happen to that inverter. Everything goes down. It will take a while, like about a minute. It's going to go down. It's going to go offline, completely offline. Okay, let's see. Okay, so we go to the next inverter. We're going to do the same. Okay, we're going to knock off the good. That guy is dead. All right, so we go to the next inverter and we knock off the solar input breakers. You see what happens? The whole system is going down. It will take a while to completely go through the shutdown process. The same thing that happens with the first inverter. Okay. All right. System is down, but the batteries are still live. You can see the green light there. You can see the green light there. The two batteries are actually software controlled. They are tied together with a networking cable. Okay, so what happens there? This is coming from inverter 2. It's going to this is coming from battery number 2. Okay, these two cables, positive and negative, coming from battery number 2 is going to battery number 1. Battery number 1 and 2 is linked with a software network cable. Okay, so right there, you have the network cable and the black and red coming from battery number 2, and then the one from battery number 1. So battery number 1 is directly linked to this circuit breaker. Okay, so battery number 1 is linked to the circuit breaker, while battery number 2 is linked to battery number 1, and there's communication between them via a network cable. All right, so let's go back and start all over again. Okay, so the first thing I do, since the system is dead, is to put on the solar input circuit breakers. That is one. Port 1 of the master inverter brings in the solar. Port 2 of the master inverter, I'm done with that. Okay, the inverter is still switched off, but it is getting solar input. Okay, it's charging already. Then I go to inverter 2 or sleeve inverter. So I inject solar into it. All right, 1, 2, 3, 4. Good. Watch what happens. Watch what happens. Good. You could see the solar icon is coming up there. Okay, after a while, that's the solar icon and that's the battery. Okay, good. It has started to charge. So it has started to charge. So next thing I'm going to do is going to power on the battery, to power on the inverter. Inverter 1, good. It's already supplying. Inverter 2, good. But normally the output circuit breakers should be on before powering the inverters. Okay, the output circuit breakers should be off before powering the battery. So I'm going to send power to the house. That's it. So that's the vent fan. The whole system is live and fully functional. Okay, now once again, as I said, I put off the vent fan. It has gone off. Okay, the vent fan needs to be permanently on while the inverter is on. Okay, because even if you are charging the inverter via solar when the inverter is not on, temperature could rise because this is an enclosed space. So if you want to charge with solar, make sure the inverter is on, because when the inverter is on, then and only then can the vent fans work. Okay, so right now I'm going to put on the vent fans again. That has come on. So system is live, the environment is cool and calm, and everything is functioning very well. Okay, So I can put off the building from 3 points. Point 1, point 2, point 3. This one brings out power directly from the inverter. It injects it into this point, which is the automatic changeover module, which chooses either the main supply or the inverter, or you could do it through this direct bypass. When it goes here, it's entirely mains. It has nothing to do with this box. It has nothing to do with this. But if you activate this by putting it on, you could select main supply to be independent of the inverter, or you take it up there where it now makes use of this automatic changeover box. So you have a direct system, you have a bypass system. The architecture of the design architecture is such that there is safety, enough safety built into the installation. Okay, we have 32 panels. Okay, 450 watts panels. Okay, so these 450 watts panels, the configuration we used was 4 panels in series for inverter 1, 4 panels in series, 4 panels in series. We now tied it together to have 8 panels, which was injected into port 1. We did the same, 4 series put in parallel, we inject into port 2. So we actually have 8 in port 1, 8 in port 2. So we have 16 panels for this particular inverter 1. We did exactly the same thing for inverter 2. So we have 16 panels for inverter 1, 16 panels for inverter 2. So we're having 32 panels in all. All of them are synchronized, okay? And everything is being injected into this box. So that's it for this. So I'm going to shut down again, okay? First thing I'm going to do, I'm not going to shut down from the inverter. First thing I'm going to do, the sequence, okay? First thing I'm going to do is to put this off. Okay, I put that on neutral. So now it's neither on the mains nor on the inverter. I put that on neutral. The next thing I do, I put this off. Okay. The next thing I do is go there and put off in that order. 1, 2, 3. It's getting here, but it's not going out. Okay. It's getting here, but it's not going out because the circuit breaker is down. After having done that, I get to this point and put up the solar input circuit breakers. 1, 2, 1, 2. Solar is no longer coming in. It has gone. This one, solar is still coming in, as you can see. So I'm going to put it off. 1, 2, 3, 4. Solar has gone off. Solar has gone off. So next thing I do is I put up the inverters in sequence. That goes off. You can see that goes off. Next one is still on. I'm going to put it off. Right there. Good. So the system is going to quietly shut down. It's going through the shutdown sequence, okay? They will both shut down completely. Takes a while, maybe a minute or 2. Okay, inverter 1 is down. Inverter 2, in less than a minute, it should go off. Good, it's off. So the system is completely switched off. So that's it for that. Yeah.